I was saying.
I'm not certain.
Okay, guys, ready? Welcome to review session number 2, or review session for exam number 2. Go ahead, ask questions. That's how this works. Yeah.
This isn't like about subject, like this isn't about something specific, but is there anything like in particular that's going to be on the exam that's not covered in homework about 6 and 10 that you can think of?
No, I think that, so you printed off the exam review sheet, so there's both a PowerPoint and there's a Word document, but I think everything in the homeworks, calorimetry, delta H, delta G, delta S, entropy, pH, all of that stuff. I mean, you know, the examples that we've done in class are very reflective of the homework as well. And so, examples that Brandon gave, class, you know, examples from class notes that we've worked through, you know, all of that stuff will be on the exam. I can't think of anything that's in the exam and that's in the notes that we didn't cover. We've discussed everything we need to.
Okay.
Other questions?
Sorry, what did I miss?
So the exam, the homeworks are very reflective of the exam, just like last time. Yeah. So just like on the first exam, right, there weren't very many surprises, and so that's going to be what the second exam is like. But the calculations are much longer. So if I ask you about free energy, what's the symbol for free energy? Delta G. What's the free energy at equilibrium, or what's the delta G at equilibrium? 0. Delta G at equilibrium. If I ask you what the equilibrium constant is,
KEQ.
that's KEQ, and how is that related to delta G 0?
Equals 1. Oh wait. It's a.
So remember, delta G versus delta G 0 are different, right? So how is KEQ related to delta G 0?
Negative RTL and KQ.
Delta G 0 is negative RTLN KEQ. So if I ask you something about free energy, or if I ask you something about equilibrium, remember delta G is delta H minus T delta S. You may have to calculate delta H from tables or something like that. You may have to calculate delta S. Then you can get what you're looking for, delta G, and then, or delta G 0 in this case. And then you're going to have to plug this thing into the equilibrium constant to get that. And so, you know, it can be a long process. So these calculations can be multi-step, just like they were on the homework. So whatever you've done on the homework, I expect you to be able to do on the exam. Yes?
What's R in that equation?
R?
Yeah, and then, yeah.
Gas constant?
Oh, okay. I didn't know if it was the same thing or not.
Yep, same thing. So you know what that is?
Okay. And then just match up the units.
Just match up the units, so make sure you're in kilojoules or joules or whatever it needs to be, and then you'll be okay. Yeah?
Is the gas constant something we should put on our sheet, or are you gonna?
I'll put it on the exam, don't worry about that. Yeah. Go ahead.
What's the difference between delta G and delta G?
Yeah. So delta G is delta G 0 plus RT ln Q. So this is, does anyone have the notes? I think this is the equation in the notes. Let me find it. You don't have the notes, I have them. I just want what slide it is. Anyone find it yet? as the computer is warming up here. Oh, zero is turned off, that's fine. So, put on blank screen here. What's going on? There we go. Okay, so anyway, so why do we have two delta G's going on here? What's delta G0? The standard free energy of reaction, right? So if I write down, okay, interesting computer setup. So if I write down, an equation like this, H2 plus N2 goes to NH3, what's wrong with an equation like this? Not balanced, that's a good answer. So it's, how do I quickly balance it? This is 3, 1, 2, right? So this will have a delta H, 0 of reaction, have a delta S, 0 of reaction, and it will have a delta G, 0 of reaction. And this delta G0 of reaction is related to the equilibrium constant. But when I start a process, or when I put in my hydrogen and nitrogen into the reactor at time equals 0, how much ammonia is there? There's no ammonia at time equals 0, right? And so the delta G of the reaction tells us how the reaction is going to proceed forward. So if delta G reaction is 0, that tells us that delta G is negative RT ln KEQ. So if delta G of the reaction is 0, that means Q equals K EQ, and I get this expression right here. Otherwise, if, say I have concentration, so what's the reaction quotient? Concentration of the products over a concentration of reactants. And so if I give you the concentration of hydrogen, nitrogen, and ammonia, you can tell me the sign of the delta G of reaction. So you can calculate this Q, you can calculate delta G0 if I give you enough information, and so you can tell me whether it's thermodynamically favorable or unfavorable for this reaction to go. So let me show you exactly the page in the notes. Okay, waiting for this. So this delta G of reaction, if I put in hydrogen and nitrogen at time equals 0, the reaction is going to want to go, right? So the delta G of reaction is going to be negative because my Q doesn't equal KEQ. So when this is not equal, delta G of the reaction is going to be negative or positive or whatever it is. And so the reaction will proceed until my Q, or my reaction quotient, equals the equilibrium constant. And then once I'm at equilibrium, the reaction stops. Delta G goes to 0, and I have this expression right here. So you can piece together what you need to calculate, whether you need to calculate an equilibrium constant, whether you need to calculate a Q, and get the delta G of reaction, because I might give you, say I give you an equilibrium constant, and I give you concentrations, and I say, is this reaction favorable or not? That means you want to calculate the delta G of reaction. So if I give you equilibrium constant, you can find delta G0. If I give you concentrations, you can calculate Q, and you can tell me the sign of delta G of the reaction. So these ideas are covered on finally getting the computer going here. So if you go to February, so if you walk through February 28th in-class lecture starting on slide 4, turn this on. You've got this expression right here. So we know delta G0 is delta H0 minus T delta S. And we have delta G0, so we can sum our reactants and products right here, just like we know for delta S or delta H0. And then we have the delta G is a function of both delta G0 and Q, and we have the definition here. And so you can march this through on slide 5. This is where we get our expression for delta G0, the reaction, negative RT ln Q. And it tells us various forms of Q. Q for a particular reaction, whether it's as a function of pressure or as a function of acid dissociation or something like that. And so, if you look at this very closely now, I'm going to skip a couple too many. So we have our expression for delta G reaction. Delta G reaction is delta G0 plus RT ln Q. And so delta G dissociation, or delta G of the reaction, in this example, is delta G0 plus RT ln cube, and we can substitute in our different parameters. So delta G0 in this case is this expression right here. And so we can get delta G of dissociation as a function of the equilibrium constant in the Q. So this is how we can decide whether a reaction is going to go in the forward direction or in the reverse direction. So we talked about slide 9